Alright, so now let's level up a little bit with some generalization of the Cobb-Douglas utility. So I have wrote it down here. So now we also introduce two constants C1 and C2, and the utility function becomes x1 minus C1, everything to the power of b1, times x2 minus C2, everything to the power of b2. With s before the exponents sum up to 1, and similar budget constraint. So we could think about this constant as the minimum quantity of goods that you have to consume in order to survive. It's something like your basic needs that has to be covered before you could improve your utility. So that is called the linear expenditure system, LES, or Stone-Jury utility function sometimes. It is like we doing now the material on slide 23 and 24 of your slide. So let's first, very standard, write down the Lagrange function, right? So in this case, the Lagrange function is a function of x1, x2, and lambda again. And it is u, which is x1 minus c1 to the power of b1, times x2 minus c2 to the power of b2, plus, right, lambda times the constraint as before. Nothing new at this stage. So I know that it looks kind of complicated, but we can do it. So first order condition. Let's write it down here. The first thing is the partial derivative of L with respect to x1 equal to, now let's take the derivative, b1 times x1 minus c1 to the power of b1 minus 1, right? The thing inside the bracket now is actually a function. So we actually must have the chain rule. But luckily, the derivative of the function inside the bracket here is 1, right? 1 times x1. So its derivative is 1. So we don't have to write it here. And then the second term with x2, now treated as constant. So we can just write it here again without doing anything else. So times x2 minus c2 to the power of b2. This is the derivative of this first part. Minus lambda times p1, like before with the Cobb-Douglas case, equal to 0. Okay, let's call it equation 1 again. The second equation has to do with the partial derivative with respect to x2. So now you have the term relating to x1 stay constant. Let's write it there. S1 minus C1 to the power of B1, right? And then it comes to the derivative of the second term related to x2. So B2 goes in front. That's why I had a place for it. Times x2 minus c2 to the power of b2 minus 1, right? And then minus lambda p2 equals 0 like before. the last one. Sorry, the last one has to do with the constraint. So with respect to lambda, which is I minus P1 x1 minus P2 x2 equals 0, right? This is the first equation. Now, let's manipulate the first two equations similar to the way we did it before. First of all, we put lambda times price to the right hand side of the equation, and then divide 1 by 2. So let's do it. One divided by 2, which is B1 times x1 minus C1 over, to the power of B1 minus 1, right? And then times x2 minus C2 to the power of B2 over, divided that by B2 times x1 minus C1 to the power of B1, and then times x2 minus C2 to the power of B2 minus 1, right? Equals. Now we put lambda and prices to the other side, and when we divide the first one by the second one, that means that lambda will cancel out. So at the end, still we have the ratio of two prices, P1 over P2, which is the negative of the slope of the budget constraint. That's what we have solved. All right. So now let's simplify this one a bit now before we move further. So B1 over B2, nothing to simplify, just write it again. Now, what is left with x1 minus c1? Above we have b1 minus 1, below we have b1. So it still have like the minus 1 in the exponent, right? And x1 minus c1 to the power minus 1, which is 1 divided by x1 minus c1, right? To the power 1. And then here, with x2 minus c2, above you have b2. In the denominator you have b2 minus 1, right? So 1 is left on the numerator. Just write it. x2 minus c2. Is that? Yeah. Now it's much more simple, much nicer, equal P1 over P2. Okay. So let's keep this in mind, and we go from there after I clean the board. Okay, let's continue. So the third equation haven't touched yet, so I write it down there. Also, this is where we stopped. So let's start from there. Now, what would we have the next? We could, for example, multiply both sides by x1 minus c1. So let's do that. And then also multiply both sides by P2. at the same time. Yeah. So multiply both sides by x1 minus c1 and b2. We would have b1 over b2 times x2 minus c2, x1 minus c1 is gone when we multiply with this, right? And then times p2 equal p1 minus x1 minus, times x1 minus c1, right? All right. And then we could even write as a p1 x1 minus p1 c1, right? And now let's first solve for p1 x1 by putting this term p1 c1 to the other side. So that is, we have, let's write first p1, not x here, not c, but should be x1 equals the whole term over here, b1 over b2 times b2, let's put a bracket in front, x2 minus c2, plus p1 c1. Alright, I call this the equations 4. And now what do I want to do with it? I will plug this term, not it, but its function, into the budget constraint, into the third equation, in order to solve for p2 x2. Let's do that. Log 4 in bracket. So what we would have is something like I minus p1 x1, which is now the entire thing over here. Sorry, it should be here, not there. Okay, minus, put a bracket there, b1, b2 times p2 times x2 minus c2 plus p1 c1. That's the entire thing for p1 x1. And then we still have minus p2 x2 at the end equals 0. Let's pull everything out of the bracket and simplify them a bit. So we would have something like I minus B1 over B2 times P2 x2, right? And then here a minus, here a minus, should be plus B1 B2 times P2 C2, and what else? That is for this term minus P1 C1, no? And then again minus P2 x2 equal 0. Now let's put P2 x2 together, like here there's one and here is another one. We wanted to solve for P2 x2, right? So, and in the meantime, we also can put them on one side to the right hand side and everything else on the left hand side. So we have I minus, no, not minus, but plus B1 over B2, P2 C2 minus P1 C1 equals, put everything with P2 x2 to the other side. So P2 x2 factor out. So what is in there? B1 over B2 plus 1, right? Now think about this term. Is this actually B1? I will write it here. So we have B1 over B2 plus 1, which is B1 plus B2 over B2 when we multiplied the numerator and the denominator by B2. And we remember that B1 plus B2 all the exponent is 1. So in this case it's actually the result is 1 over B2 is like of this term. Yeah? Let's put it down here. And we write it as B2 x2 times 1 over B2, right? Finally, we could solve for B2 x2. So B2 times x2, which will equal, because now we have B2 in the denominator, so we would have to multiply both sides by B2, right? So here B2 x2 equals B2, have to multiply by B2 now, I plus B1 over B2 times B2 C2 minus B1 C1. And how to do that then further? So you can open the bracket, pull everything out. So B2 I plus I well, actually, it's right. B2 times B1 over B2 times B2C2 minus, again, B2, right? Times B1 and C1. How to simplify it further? So here, let's open another think box to shorten the progress a bit. So, because B1 plus B2 equal 1, so we could actually write B1 as 1 minus B2, right? Here, simplified. So here we have B1. So actually, for that reason, we have B1 times P2C2 would be 1 minus P2 times P2C2, right? And H equals P2C2 minus B2, P2C2. Let's bring this guys, substitute here and see what we get from that. We write it again, B2 times X2 equals here B2 times I, right? Plus this one. Sorry, not B but P. So it's like P2 C2 minus B2 P2 C2 again. This is for this term. Now this term. Another time minus B2 P1 C1, right? And now we can put B2 out because it's shared by many summands in here, right? So inside there we have I. There's no B2 in here. Skip it for now. Here minus P2 C2, right? But here minus P1 C1. So let's write it first. Also with P2. And then go back to P2 C2. And plus what? B2 C2 out of the bracket. So I put a box around it to highlight the result. This is the result that you should get on slide 24 for the expenditure on X2. Now, and actually we could also derive further for B1 with P1 X1 by substitute this term already back here, right? So you have B2 X2, sorry, you substitute X2 in here or back to the budget constraint, and then you derive a little bit for a while, but at the end you will get, I open another box again, P1 X1 will equal B1 times, I take it slowly so that I don't make mistake, minus B1 C1 minus B2 C2, close the bracket, and then plus B1 C1. Yeah? This is the expenditure that you would spend on X1 in order to maximize your utility. And so now think about it a bit. So the first part is, no, it's actually the second part, but let's start with it first. So this part is the expenditure that you have to spend on a committed, on the minimum amount of goods that keep you survive. So this is the first part of the expenditure. The second part is the exponent itself times what is inside the bracket. So like the income minus all the compulsory or all the committed expenditure. Similar interpretation here, but now we deduct all for all goods from the income. So it's kind of the free income at the end that you still have after covering your basic needs.